Okay, guys, let's look at the second student task statement called Plants, Bicycles, and Crowds. Number 1 is saying the instructions to care for a plant says to water with 3/4 cups of water every day. The plant has been getting 25% too much water. How much water has the plant been getting? Okay, so we need to do some annotations. The plant the instruction says to give the plant 3/4 cup of water every day. But the plant has been getting 25% too much water, and the question which I'll circle is how much water should the plant be getting? Or how much water was the plant getting? Okay, so we're trying to figure out, well, it's supposed to be getting 3/4 cups, right? But it's getting 25% too much water. All right. I'm sorry about that, guys. That was my phone. But the first thing we need to understand is that 3/4 cups is the original amount. Okay. This is how much it is supposed to be getting. And it's getting 25% too much water, which means that we're trying to find 25% of 3/4. Okay. Now, the reason why I'm going to say let's look at 25% as 1/4 is because I think it would be easier for us to kind of like go over it as a math problem. So 25%, we want to change it to 25 over 100, and that will simplify to 1/4. So I want to find out what's 1/4 of 3/4, and I want to see like add the total amounts together, okay? So the first thing we need to do is find 1/4 of 3/4, because remember 1/4 is 25%, okay? So when I do that, I'm going to multiply going straight across, and when I multiply going straight across, I should get 3/16. Okay, 3/16. Now, once I get 3/16, this tells me the 25%. This is the 25%. Okay? So what I want to do is I want to add that to the original amount because it's saying that it's 25% too much. So I have 3/4, which is the amount it's supposed to be getting, plus 3/16. Now, anytime you add fractions, you do not want to add them when they don't have unlike denominators. They have to have the same denominator. So I need to figure out how can I get 4 to 16. If you guess, multiply 4 times 4, and whatever you do to the top, you want to do to the bottom, you are absolutely correct. So when I do that, I should say, okay, this is 12 over 16 plus 3 over 16, which is equal to 15 over 16. And I want to put cups of our cup. 15 over 16 cups of water. Okay, that is our final answer. All right. So now let's look at number 2. They said the pressure on a bike tire is 63 psi. That's like the pressure unit or something. This is 5% higher than what the manual says is the correct pressure. What is the correct pressure? So we're looking for the original amount, and then I'm going to refer to our proportion tables, okay? So all percents go over 100, but it's 5% higher. So this is surpassing the original amount of the percent, which would be 105%, okay? Because it's going over the original amount, and which we don't know the original amount, so I'm going to put an X. All right? And then it's going to be 63, because 63 is 105% comparing it to the original amount. The reason why I put an X, and I'm going to put that X is the correct pressure. Let's put that. X is the correct pressure. All right, guys, so I know we've been doing the high heel method, but I got fussed at my PLC today for saying that terminology. So we're going to cross multiply to figure out, well, what's the missing number, or what's the correct pressure? So I'm going to cross multiply x times 105, 63 times 100. So it's going to be 105x is equal to 6,300. All right, so now my goal is to isolate this variable, which I'm going to divide 105 on both sides. All right, so when I divide 105 on both sides, and which, yes, I am using my calculator at home, and you guys feel free to use it on your test. When I divide those two numbers, I should get the correct pressure is 60. All right, so if I have to write this in sentence form, the correct pressure is 60 psi. All right, so let's move on to the next one. It says the crowd at a sporting event is estimated to be 3,000 people. The exact attendance is 2,486 people. What is the percent error? Now, we see that this new vocabulary term, percent error. And basically, an error is something that's wrong. And percent is trying to figure out, well, what's the percentage you got wrong, okay? So I'll give you guys an example. When a teacher creates a test, we create a test and we put all these questions on there, and we're hoping that a student would get a 100% on a test. So say, for instance, a student takes the test and they score at 80%. Well, if I was assuming that the student was supposed to get 100% of the answers correct, my percent error will be 20% off because this person scored at 80%. All right. So that's just kind of like a brief way of me explaining percent error. It's just basically the percent of the mistake. Like, you calculating the percent of the mistake. Okay. So what we can do is we can find out, well, what's the guess? The guess is they estimated that 3,000 people was going to be there, but the exact people that came there was 2,486 people. They're trying to find the error. So what I like to do, now some people may not agree with this, but I like to start off with subtracting. I want to find out how much off they were. So I want to start off subtracting. I want to subtract the guess, and I always refer to it as the guess or the estimate, which, let me use those exact verbiage the question used so you can refer back to it in your notes. So the estimated guess, okay, and then I want to subtract those two numbers. Okay, so they're about 514 people off. Okay, so I want to put, what's the amount of people that showed up? The amount of people that showed up is 2,486 people. And I want to put how much they were off by. Okay, we're trying to find a percent that how much they were wrong. Okay, so 100%, of course, that's the original amount of people, or the amount of people that showed up in total. And we're missing the percent, and I'm going to put X, and X is going to represent the percent error. Sorry about that. I spelled percent all the way wrong. Okay, so now I'm going to cross multiply. And when I cross multiply, now I have my equation set up to where it's going to help me find the percent error. I want to isolate this variable to put it by itself. And I'm going to divide both sides by 2,486. That cancels out. And X And yes, I am using my calculator right now. So divided by 240. And what I get is 20.675. 57. Okay. So it should be you are about, or this person is about 21%. This is the percent error, about 21%. Okay. If you wanted to leave it as a decimal form, you can, but we could round to the nearest tenth. Okay. So if you guys had any questions or issues with this question, guys, please make sure you visit your manager's Google Meet session. There was a new term that was introduced. So, of course, a new skill was taught. So it's kind of like, it's okay for you if you struggle today. But if you don't get it, make sure you visit your manager's Google Meet session. And I'll see you guys in the next problem.